Okay, so we're back now, and we've just finished a look at kinematics, which is the study of motion. And we want to look at motion in a different way, a little bit deeper, add some ideas to it. And we're going to talk about something called dynamics. Dynamics. And let's define that. It's the study of the causes of motion. What makes things move or change their motion? Well, there's a name for that. The motion of objects, their change in motion, is caused by force. So here's a new quantity in physics. It's a vector, symbol F with a vector. And the unit for force is the Newton, named after the great scientist Sir Isaac Newton, who did a lot of work in this area back in the 1600s. So to put it very, very simply, a force is a push or pull on an object. And forces can cause an object to change motion. If you have a ball and you throw it, you apply a force on that ball. If you pull someone in a wagon behind you, you're applying force on that wagon. You're getting it moving. The friction of the snow on the bottom of the sled, all these things provide forces. And we're going to go through these ideas step by step, identify different forces, and the rest of it. Now, a Newton is the unit for force. 1 Newton is actually a very small amount of force. It's tiny. What will 1 Newton do? Well, 1 Newton will accelerate 1 kilogram of mass at 1 meter per second squared. So picture yourself out in outer space and you push on an object with 1 Newton of force, and that object has a mass of 1 kilogram. After 1 second worth of pushing, the object is moving at 1 meter per second. That's its velocity. Add another second worth of pushing, and the acceleration is 1 meter per second squared, so it'll now be moving at 2 meters per second. It's speeding up. After 3 seconds worth of pushing by this 1 Newton force on this 1 kilogram mass, it'll be moving at 3 meters per second because its acceleration is 1 meter per second squared. So that's what I've written here. This 1 meter per second squared worth of acceleration on this 1 kilogram mass that's being pushed with a 1 Newton force. This is the result of the push. Every second that goes by, you pick up 1 meter per second worth of speed, velocity. So what's really important to understand here, that force causes motion to change, and we see that change in motion as an acceleration. Force causes velocity to change, and changing velocity is known as acceleration. Now, forces can be divided into two main categories. One of the types of forces is called a contact force, where there's a physical contact between the objects involved. Example, a hand pushes on a ball, you push against a wall, a, a, uh, a dog pulls on a toy at one end and you're pulling on the toy at the other end. There's contact between the dog and the toy and you and the toy. Contact forces. Then there's also a group of forces called non-contact forces, also known as action at a distance. There's no physical contact between the objects involved, nothing. Example, a ball being pulled down at the acceleration due to gravity, negative 9.8 meters per second squared. There's no contact between the ball and the earth, as the earth's gravity has an effect on the mass of the ball and it's being pulled downward. There's no contact between the sun and the earth, as the sun's gravity keeps the earth in an orbit around it. So it's acting at a distance. There's no physical contact. All right, well, what are some of the common forces that you are going to look at in this physics course? Well, one of the common forces is force of gravity on an object near Earth's surface, Fg, little g there for gravity. It is also known by another name, weight, with the symbol W and an arrowhead. It's most definitely a vector. So what you've commonly known as weight is also known as the force of gravity. The force of friction, F, F, and there's many types of friction. We're going to look at them in greater detail and break it down into the different types. But in general, force of friction. The force of friction opposes motion and the start of motion. If you ever try to push something along a floor and it's scraping along, right? Or if you ever try to start something moving, say, I can't get this thing moving. I got to push real hard and then it starts to move. You're working against friction. Now, frictional forces are always parallel to the surface. Next, FT or just T arrows, heads, they're vectors. Tension, force applied through a string, a rope, or a cable. So if you're pulling something, dragging something along with a rope, there is a force administered by that rope called tension. You've probably heard of that word before, but now it has a very technical meaning. It's a force applied through a string or a rope. Next, normal force. You might not have heard of this one before. Normal force. It's the force from a surface onto an object on that surface, and it supports it. It keeps it from falling through. So if you're sitting on a chair right now, the chair is providing you a normal force. It's pushing upward on you so you don't fall down. Now, chairs can collapse. I've seen it happen where a friend of mine used a chair that obviously has been broken. He went and sat down on the chair. Boom, fell to the ground. The chair couldn't hold him up. Or what a scientist, a physicist would say is the chair could not provide enough normal force. I remember as a young lad walking onto a friend's porch, veranda. I took a few steps and then boom, my leg went right through the veranda. Why? Well, some of the wood was rotted out and I fell through, or at least my leg did. Or as a physicist would say, the veranda, the porch, the deck could not provide enough normal force to support my leg, to support me, fell through. Normal forces, unlike frictional forces, normal forces are always perpendicular to the surface. They push up. Now, to help us study forces and their effects on objects, on mass, we draw something called a free body diagram. Very straightforward. Any object, me, you, an elephant, a bunny rabbit, is drawn like this. That's the object. Well, no matter what the object is, there you go. That's where you draw it. It's a box, square, rectangle. Then forces are drawn as arrows, like that. Now, the diagrams show all the forces acting on an object. So here's an example. Mr. Z stands on the floor. Well, there's my picture. There I am. There's Mr. Z. And there's a normal force because the floor is holding me up. And I'm on the planet Earth, so there's the force of gravity. So I draw the arrows and I label them. And there's our first free body diagram. How about Mr. Z pushes a tray? So think about me pushing a tray on a surface. And I'm pushing it, so there's force P, push. Some people call it applied force. There's the force of gravity, it's on the Earth. There's the normal force, the surface holding the tray up, and there's the force of friction. So there's your second free body diagram. How about tray slides on the surface? I'm no longer pushing it. I pushed it a while ago and now it's sliding on its own. Well, there you have it. Normal force, it's still on the surface. There's still a force of gravity acting on it because eventually it will come to a stop. The slide will stop, and we're on the planet Earth, so there's a force of gravity. So look, I've drawn the three arrows with their direction, and each of them are labeled. So there you have it. There you have it. There's an introduction to forces, and we'll give you some homework and reading to do, and we'll see you next time. Bye-bye.